What is the remainder when the two-digit positive integer x is divided by 3? So our options, if we're dividing by 3 for remainder, are just 0, 1, or 2. So without even knowing anything about x, we're already very limited in terms of our options. So now let's look at the statements. The sum of the digits of x is 5. So here, what are all our two-digit options? So we could have 14, 23, 32, 41, and 50. And what is our remainder when we divide by 3 here? So 14 over 3 is going to be 4, remainder 2. 23 divided by 3 is going to be 7, remainder 2. And then 32 divided by 3 is going to be 10, remainder 2. And so it looks like this is going to be sufficient. And you can sort of see the pattern. So if we were talking about the remainder when we are divided by 3, every 3 numbers, our remainder is going to repeat. So if it's going to repeat every 3 numbers, then it's also going to repeat every 6 numbers, and it's also going to repeat every 9 numbers. And that's what it looks like we have here. So based on that, I know this is all going to be the same remainder. This guy here is sufficient. Statement 2 says the remainder when x is divided by 9 is 5. So I can write that as x is equal to 9y, where y is just some positive integer multiplier. 9x is equal to 9y plus 5. So if y is equal to 1, for example, x is equal to 14. If y is equal to 2, x is equal to 23. And then from there, it's going to go up by the same increment, which happens to be 9. So our list is going to be the same list as here. The only difference is actually we can keep going, though, right? Because here we were constrained by the fact that the sum of the digits had to be 5. Here, so like we left off some of our two-digit options because we could stop here. Here we can keep going because we still got some two-digit numbers left. So 59, 68, 77. But the point is we don't actually have to test these numbers because if we know the principle that, every 9 numbers, the remainder is just going to keep repeating, these are all going to be remainder 2. And therefore, our answer is D.